Greetings and welcome to my new calculus channel. My name is John Gabriel. So I think I've shown you this. I think you'll be able to hear me better now. Greetings and welcome to my channel. My name is John Gabriel. In the past, I have shown you this number poster that you see in front of you. It gives you the perfect realization of number in 7 steps. Okay, doesn't need anything. It's complete. It follows logically from each previous step, and it tells you every single thing you need to know about number. Okay, and I'm going to explain that to you today and why it's true. Now, a number is a name, just to summarize, that is given to a measure that describes a ratio of magnitudes with quotientness. Okay, so the first step says, look, you need something that refers to size, and that's what magnitude does. The Greek word is megathos. It refers to the concept of size, it could be dimension, extent, etc. It's not a number, okay? Not a number. It refers to size, mass, area, volume, density, whatever. Now, if you come to me with any particular object that has one of these attributes, like let's say length or distance or mass or area, and you try to tell me about it without showing the object to me, it's not going to help, okay? So you need to relate that magnitude to me by using a magnitude that I already know. So for example, you can say, take the length of your hand. The object I'm referring to is 3 times the length of your hand or half your hand or something like that. Okay? In other words, it leads naturally to the ratio. Okay? What's a ratio? It's a comparison of magnitudes. Okay? And we call that ratio a ratio of magnitudes because it tells us what's being measured and what is measuring it. Okay? What's being measured is by convention the antecedent, and what measures it is the consequent. The consequent later becomes the standard measuring tool, the unit. Okay? And so we decide that once we have a measuring tool we want to use, any arbitrary measuring tool, then this particular ratio where the antecedent is measured by the consequent exactly once is the unit. Okay? The fourth part is where most of you trip up and where this gentleman here tripped up. Okay, so he says to me, how would you describe how this changes in algebra? So I was telling him that you cannot say that 12 colon 4 is equal to 3 colon 1 because they're ratios. Okay, they're not numbers. You can say that 12 over 4 is equal to 3 over 1, but not these ratios here. They're numeric. And why do I say they're numeric? Okay, well, let's start off with geometry. Okay, so in geometry, not algebra, we start off with a ratio. Here's a line segment, this red-blue line segment. The first part is the antecedent. The second part is the consequent. Okay, now here comes the tricky part. Step 4. Step 4 here says, does this ratio here have quotientness? Even the Greek morons of today in Greek universities don't understand this definition of Euclid. What it means is, does this ratio have a common measure for its parts? In other words, is there a magnitude, not a number, a magnitude that measures both? Okay? Is there? Okay, well, let's see. So in this case here that we're looking at, I'm giving you an example. This ratio has quotientness. Why does it have quotientness? Because this little green line here measures all the antecedent and all the consequent without remainder. Okay? I don't even have to count. Don't even have to know anything about numbers. Numbers are not even around at this part. That's what quotientness or pilikotita means to you Greeks. Είσαστε πάρα πολύ ηλίθιοι και δεν ακούτε. Και αυτό είναι πολύ δυστυχώς πράγμα. Okay, let's get back to what I'm saying. We can form numbers using this common magnitude. How, you ask? Well, in this number poster I show you. I say let 1 be the measure of what you chose as the measuring magnitude, like that. In other words, it's equal to the antecedent. Let 2 be the measure of the ratio where the antecedent is where the antecedent is the consequent lined up with the consequent again itself. Okay? I didn't want to say added. Similar story with 3, 4, etc. So that is what I'm doing here. I'm saying let's form numbers, special numbers, counting numbers, 1, 2, 3, etc. Right? Number 3. Now we can count the number of equal parts in this ratio up here. Okay, here in this ratio, we can count them. We can take this little green part and go 1, 2, 3. That is the measure of that line segment, and 4 is the measure of this one. Okay. And finally, we can write down a number from this. How, you ask? Very easy. We just take the measure of this ratio. Now, there are 2 ways to do it. We can just write down the measure like this, as you see in step 5, or we can write it out numerically as a ratio. 3:4. That is not a fraction or a number. For fuck's sakes. Now, 3/4, or 3 divided by 4, which is 3/4, is equal to the measure of this ratio. Right? Does that make sense? So, what I have shown you, morons, is the complete derivation. Then you ask, well, what about ratios which don't have quotientness? Well, then you get to step 7. It doesn't have measure. The ratio doesn't have measure. Can you guess a ratio that doesn't have measure? Circle circumference to diameter. Square diagonal to square side. Those do not have measure. Okay, those are just constants which are approximated. So I hope now that all of you understand the perfect derivation of number. It doesn't require you to think about it, or even God to think about it. It's correct, as I've just told you. It's 100% correct. You get that? Stop your video and think about what I've told you, morons. I'm calling you morons because that's what most of you are. But hopefully after this video, you're going to start being smart. Aren't you? Okay. So that's how you realize number. So I carried on this discussion with this guy. He's a smart guy, but he's a real pain in the ass. Okay. So then he says, how would you describe how it changes in algebra? I just did. I just showed you the transition. Look, I showed you. I showed you how you start from geometry and you go all the way right through to algebra, which is a step here. Nothing else to do. So what would be different in geometry gets automatically simplified in algebra. You see, he thinks that 12:4 and 3:1 are equal. They're not. They're not equal in anything but measure. okay, because they're not numbers, they're ratios. Okay, 12 over 4 does not equal to 3 over 1. So if you want two ratios to be equal, then the antecedent must equal to this antecedent, and the consequent must equal to this consequent. Otherwise, the ratios are not equal. But the measure, which is 3, is equal. Okay? So the measure of this ratio is equal to the measure of this ratio. And he says, however, this feels like a just so story because I haven't described the transition with the precision that I want. What the fuck is he even talking about? Here's my answer to him. Geometry starts a measure with a ratio of non-numbers, which has quotientness, and algebra gives it a name. Non-numbers, see? These are non-numbers here, these lines. Do you see that? And eventually we give them a name, 3 over 4. Isn't that neat? Okay, if the ratio is already numeric, like 3, 4, there's almost no work to do in algebra, since the measure of the numeric ratio, 3, 4, wish these bloody things would start here. The measure of the numeric ratio 3 colon 4 is simply 3 over 4. In geometry, a lot happens before one gets to 3 over 4. A lot. And 3 over 4 does not mean 3 divided by 4. That's already happened. It's already happened. It's in the past. There's nothing to do. No. 0.75 is not 3 divided by 4, you fucking idiots. It's the representation of 3/4 in base 10, and there's a lot more than division going on there. Okay? Now, 3 colon 4 is a ratio. 3 over 4 is a number. They are two very different things. Numbers are abstractions. Whether you think about them or not, they've always been around in past perpetuity, and they'll continue to be around indefinitely, whether there's anybody to think about them or not. They're inanimate. They don't breathe, they don't shit, they don't eat, they don't sleep, they don't masturbate. They're just there. They're platonic. That's why Plato was such a genius. Okay, the initial green line, which is a common measure in the above illustration, is no longer relevant in this illustration. This initial green line is no longer relevant when we get down here. Can you see that? Neither its length, which or its type, could be area, could be mass, doesn't matter. No longer relevant. The numbers are abstract. So, this isn't a just so story, as I've shown this guy so many times. It's 100% clear. And so he irritates me because he's asking questions which I've answered 1,000 times, not once, but 1,000 times. So I hope that you now understand what is a number, okay? And of course, this guy's objections can be classified into these categories. He posits a requirement, and in applying it, he overlooks critical aspects, leading him to the mistaken conclusion that the work contains errors. It has no errors. He assumes the existence of a requirement when none in fact exists. Then he projects his preconceived notions, whether consciously or subconsciously, onto my work, as if such a projection could establish correctness or confirm the validity of knowledge that is itself unsound. And he attempts to dissect the concept into innumerably many pieces, which is a super task, okay? You can't do that. Indefinitely many fragments means such an effort is unproductive. You can't complete it. Number 5, he implies the existence of alternative approaches, but he is unable to articulate them. And then, of course, he usually quibbles over what the meaning of a word means. Typically what a mainstream math academic does, a Zelos Malem or a Marcus Cliver, or some idiot who says, but you're not using it with the same meaning as we are. Yes, I am, you fucking baboon. I'm using the dictionary definition, And that's where the word starts. Okay? And if you don't know a word, look it up in a dictionary. That's why there's a dictionary. Okay, and if you mean something else in mathematics, it doesn't mean you're right. It just means that that's what you think. Because there are ill formed definitions and well formed definitions. Most of what you think is syphilis. So, in other words, it's crap. Most of what I think is light, beauty, clarity, and brilliance. The majority, the majority of you are fucking morons. So, these are things you should have understood from a long time ago, but you're still battling over it, okay? Now, that's pretty much it. I think I've gone over time in this video. I've tried the best I possibly can to explain to you. The number poster, by the way, that I shared with you is what should be in every lecture room, math lecture room, in every classroom, because professors of mathematics have no clue. They don't even have a definition of what number is. They don't know where arithmetic comes from. Okay? They produce millions of asswipe research papers which have gone nowhere in the last century and are going nowhere, and they wonder why students don't understand mathematics and why they're losing interest, because their educators do not understand. Listen, if you're not a rare subscriber, click subscribe. You've got nothing to lose. Nothing. Okay? You'll be supporting somebody who's been enlightening you, educating you, telling you the truth, not worrying about what any nincompoop thinks, because I don't even care what God thinks. Basically, if God had to tell me I'm wrong, I would tell God he's a fucking idiot. That's how confident I am that I'm right. Okay? Think about that. You can say that. Don't you dare say that, because your IQ is like a baboon, probably. I can say that you can't. I am an exception. You are not an exception. Don't you dare say that. I don't care if you're a Field Prize winner or a Abel Prize winner. You're a fucking moron next to my intelligence. Don't you dare say that you would tell God that. You don't know any mathematics. Click subscribe, follow me on academia.edu, and stop masturbating. I mean, your brains are so slow as they are, and they're just getting slower. Please, just cut the masturbation out. I'm John Gabriel, and this is the New Calculus channel. Till next time.